left off on the last video was page 159, where we went through this worked example and we had to figure out what value of A made the entire area underneath the curve come out to be 1. So a lot of the examples that we have in formative task 26 and in past exams are very similar to this. Let's have a look at the next example. Very similar again. We're finding what value is going to make it true that the entire area from negative infinity to infinity for that function comes out to be 1. Since x is only defined from 0 upwards, we can shorten that to 0 to infinity. On your CAS calculator you can enter that infinity symbol, of course, and you should be able to just solve that for A and it'll come out to the answer. Here's another example. This time, instead of having an A multiplying in the function, we've got to figure out what n terminal is going to make this come out to be an area of 1. But same sort of problem again, where we can solve this on the calculator. We just need to enter that into our CAS calculator and solve comma A, and it will do it for us. But as you can see there, you can also do this manually. You might also be asked to find probabilities. So x is less than, that should be just one decimal point, 0.75. Just enter those two terminals and it'll give you the answer. Don't forget that for any continuous distribution, the probability of x being equal to a particular value is always 0. So you don't have to reach for your calculator for that. So today I wanted to have a quick look at a mean, median and percentiles. E to the x, our mean or expected value, is given by that integral x times function x. Sometimes in our calculations for, say, variance, we might have to find e of x squared. Any function put inside that bracket there simplifies to the integral of that function times the function x. We'll see that in action in a minute. And in case you've forgotten about medians, quartiles and interquartile range, just a reminder that your median is also called the Q2 or quartile number 2. That median is, for continuous distributions, defined as the x value that divides the function's area in half. So it's the halfway point on the area. The lower quartile is the lower quarter point, or 25th percentile, where it's equal to 0.25 or a quarter. Q2 is the median, Q3 is the upper quartile, and that's the 75% mark, or the 3/4 of the way. So that means that in between your lower quartile and upper quartile, bottom quarter and top 3/4, in between those two, you've got half of the data, half of the area in the interquartile range. So let's have a look at using that in action. So here's a random variable. We're told it's a probability density function, so we don't have to check. We know that that means it has to have an area of 1 from negative infinity to infinity, or in other words, the integral between 0 and 2 would have to be 1. To figure out e to the x, it's just x times function x. and I can go ahead and do that either manually or on CAS. To get e of x squared, it's x squared times function x. Do it manually or on CAS. To get e of e to the x, it's e to the x times function x. Again, manually or on CAS. Or I suppose you'd really need to use CAS there, wouldn't you, to get the e to the x values. If you had to figure out medians and quartiles and interquartile range for this function here, x cubed on 4, then we go from this m value, the median, 0 to the halfway point of the median, gives us half the area. Solve that on CAS. So it's just solve, type that in, comma, m, and it'll give you the m value. Lower quartile, pretty much copy what you did over here, except change the 0.5 to 0.25. And likewise over here, change the 0.25 then to 0.75 and solve. Note that in each one of these three, you had to pick between the positive and negative values for this particular function, because of course that function, although it's not defined for negative values, has got a symmetry off to the other side of the origin. So on a graph, that's what it looks like. We have this part of the cubic. It's only defined from 0 up to 2. And there's what our three values look like. So between 0 and this blue line, we have a quarter of the area. Between this blue line and pink line, we have another quarter of the area. Between the pink and green, there's another quarter. And between the green and 2, we have the last quarter. So it divvies the continuous distributions area up into 4 equally sized parts. So you can estimate that visually if you've got the graph there too. In between this blue line and the green line, those middle 2 quarters add up to a half. So you've got half of the area contained in that interquartile range. So the interquartile range here is 0.447. That means half of the data is within 0.447 in the difference of those two x values. Okay, measures of spread. Standard deviation is the big one. Variance is the calculation that we use to get to that measure of spread, the standard deviation. It's defined as e of x squared minus ex all squared. Let's have a look at it in action. So we've got ourselves a probability density function. We've verified that over here, that the total area is 1. We've checked that it's a function and that all values are 0 or positive. So that's all good. To find the mean, it's x times function x is our rule. We have to cover everything from negative infinity to infinity, and since it's a 0 all down there and 0 all up there, we can simplify that to -4 to -2. All we need to do is then throw that into CAS, and we get our answer of -8/3. To find the variance, e of x squared means it's x squared times my function. Take away ex all squared, well, we just found ex up here, -8/3, so it's -8/3 all squared. Again, throw it into CAS, we get our variance. And the standard deviation is just the square root of that value. The median, I've got m to -4, so it's the bottom defining point on the graph up to the halfway point. We could probably see it looks to be around about there. I'd rate it at about -2.5. Looks visually to be the point that cuts that area in half. But putting it into CAS with a comma M, solve, comma M, will give you your answer of -2.58. Here's another example. Again, x times 2x to give you your expected value. E of x squared, take away e of x all squared to give you your variance. You can also be asked for things like e of 3x minus 1 or variance 3x minus 1. And we've got those rules that we learned earlier about how to convert those into more simplified, workable forms. Okay, so that means that you are up to not formative task 28, but formative task 27 to have a crack at. So try those questions out.